Hello, Gaz here, and I wanted to talk about like the architecture we use with LLMs, right? So first, if you have any questions, just let me know as well, right? So how do we do that? So if you use LLMs, so imagine like this is an LLM, right? And then you might use any other model as well, right? So then what you do is first probably need to make sure my microphone is actually set up correctly as well. Yes, it is. Okay, so what you're going to do is to say, I'm going to send something to this LLM and get some sort of output, right? So this is, I guess, everyone's imagination of the architecture, right? So this is what's happening. So, but in reality, when we go to the company and then imagine like you're working for a different company and your company might be Airbnb, it wouldn't be the case that your company just uses one LLM. So that's not the case, right? So we can't put the entire Airbnb into one agent and have this massive prompt to handle everything. In reality, what happens is Airbnb probably has multiple domains. So each domains are different. So then for each domain, you probably have like, for example, booking, you have different domains like listing, so on. And your request probably goes to each one of them separately, right? So you probably go to this one, and then you have another one that goes to here, right? And then you get the output differently from each one as well. So that's pretty good. So what happens in reality is part of this system. So imagine like we had one endpoint, we're gonna replace that part of the system with just another one. So imagine like we're gonna have one LLM, a really tiny thing that sits within this booking system. So from now on, within the booking, we might send that specific URL or that specific request to that LLM and just get a response. So LLMs, if you go with Airbnb, ends up like a lot of like systems that just go directly, and some of them they just have these little LLMs on the middle, right? So if we go with something like a huge company like one Airbnb, they probably have around 1 million little agents, or they might end up there. So each one of these little LLMs, they're gonna do what we expect them to do, and that's how we can make the LLMs a bit more deterministic as well. So this is the case. But how do we like what are the architectures? So there are like five architectures that everyone uses. One is if you use prompt chaining, right? So this is the fact that you can actually do, and we're gonna talk about that as well. Another one, so I've got this one in my course that I'm actually presenting on the production ready. And then you can actually go to um, the why demos die. And if you go, I think one of the slides, you can actually see them as well. So we have prompt chaining, routing, parallelization, orchestration, and so on. So routing, and then we have let's talk about the other one, which is the parallelization. Let me see the typing. I just copy paste it. And then we also have another one, which is probably Orchestrator-worker. And then we have Evaluator-worker as well, right? So then we also have Evaluator-optimizer, right? So these are the cases. So with the prompt chaining, what happens is you have a you have a system, you probably have some sort of validation in the middle. So this is validation. And then you go and then call an LLM, right? So imagine like if we want to classify OP issues. So then you go to this LLM, and then this LLM, you definitely need to validate your result. This is another code level that you need to validate. And then at the end, you need to call another LLM to give you a proper response or write something good, right? So if it's failed, you probably just fail it. But if it not, you go and chain the system, right? So now you have this LLM that it just, for example, identifies or classifies OP or production issues. So that's what it does here. And then you have another one here, which probably writes a proper response. So you can see I started drawing some sort of, architecture here. So you can do that with the prompt chaining. The other one we use is called routing. So again, something comes to the system, you first validate whatever the prompt it is, and then you're like, okay, so depending on what the prompt is, I want to do different things. So imagine like, is a simple message and it's a chat message. You want to have an LLM here that decides what to do. If it's like a simple greeting, if it's hi, it might send it to this model. And if it's something else, it might send it to another model. And if it's, for example, you want to actually do a refund, it sends you here. There are different ways, and each one of them needs to be validated again. And then you go here, right? So this one we started routing. So this is a classification routing, for example, or what we do, we could just call it routing. And this LLM sends it to this LLM. This is probably greeting. This is probably complex query. And the other one is, for example, refund handler, right? So then you can do that by just saying which one you want to do. This is called routing. So sometimes we might do that as well. The other case is there is again a prompt comes to a system, but because of this prompt, we might call different agents in parallel, right? So different agents are hello. Yeah. So we're talking about architecture of different AI agents. So we talked about prompt chaining, we're talking about routing, and then now we are in parallelization. So if you go with the LLM and then you comes here and then you get it here, but you might end up wanting to do parallel things together. One of them might be, this is really common if you use ChatGPT and so on. One of them might be research. One of them might be, for example, browser check. One of them might be, for example, RAG system. So then you end up doing parallel queries to different systems using LLMs. And then at the end, you probably validate each one and then you combine them with another one, which is like a response writer, right? So you write the response, the end, and that's how we do. So we do parallel things together, and that's what's called parallelization as well. There is another approach, and this one is pretty good to do as well. So imagine there is like a bigger system. So I go here, and then there is again another prompt come to our system. We validate it. Don't forget, we need to validate all the prompts. And then the prompts goes to the system. So the system has different phases, right? But this system, which is like this LLM here, it has more autonomy as well, right? So this LLM can decide to do what. So we might give it different flows, different workflows, different tools, or whatever. This LLM decides to do what, right? So the first time it might be a refund. So if it's a refund, then LLM might actually decide to call check user, check policies, and then it might decide to call, you know, a refund action. So what it does is makes a new workflow based on the access that it has. Then it calls them sequentially or in parallel, and then does a refund. Or you might give it like another one, which is, for example, a purchase. So LLM just decides this time for a purchase, I want to send a message first, and then I want to actually let them purchase. It's so what it does is the LLM decides, you can pretty much guide it as well, but LLM decides what to do because of the scenario, right? So if the prompt of user is buy, but before send a message, we can actually go and make a unique workflow for the system by having an orchestrator in the middle. So this is called workers, and then each one of them is decided by orchestrator, so you can call each one differently as well. This is a really powerful method. I guess just making sure you control it very well is also important as well. The other one is what we want to do with validation, right? So we talked about validation. So this is a code level validation of prompt. And then usually the system goes to another LLM here, but for any reason, we might want to validate this system. So we have two ways to validate. So we probably do a code level validation here, code level validation. But what if we also want LLM validation, right? So LLM validator. So you might call it guardrail as well, right? Guardrail. Or you might call it, security check. So whatever you want to do, you can actually do that as well. So this is an example of some sort of validators that we always put in place for just making sure we're still following the practices as well. So in reality, if we go with the company, it might end up one of these fives. So if I go and I have a chat system, I probably start say, okay, so I need to validate it, then probably goes to, for example, simple prompt chaining. I need to identify, then maybe I have workflows defined, so I do that. And maybe I define a classification and it goes to another system that might be an orchestrator. And the orchestrator might have different workflows, or it might actually go here, and then there is absolutely always some sort of like LLM at the end that it just checks everything as well. So you might do that. Might become your architecture, which is a combination of all of these systems. So whatever it is, you want to make sure you follow these practices. And the other thing is you always want to have code level validation. So you can't just trust LLMs to do everything. This is exactly the trap. So just don't do that. Just be sure that you always have code level validation before or after, because LLMs can be tricky. They confidently tell you a lie, and you don't know if that's true as well or not. Any question? Yeah, so if you don't have any question, if you go to Maven, Gazar, or if you go to Gazar.dev, you can see I've got more Mavens. I've got a cohort as well that's coming, like two courses I'm actually organizing. One is the from senior to staff, and another one is production ready systems with LLMs, which I started opening their cohorts as well, so you can absolutely join them as well. And then the other lightning sessions as well. I've got it on the website. You can go with each one of them: AI, supply chain, threat model, and um, you know your agent tool chain. And each one of them hopefully becomes really useful to your daily work as well. So keep that in mind. I'll also share them on my YouTube as well, so you can absolutely watch them too, over there as well. Yeah, thank you so much, and I'll see you in the next ones.